I'm Catherine Stevens from the American Chemical Society. Welcome to this news briefing from the ACS Fall 2020 virtual meeting and expo. We're joined today by Dr. Zhongzhe Liu from California State University-Bakersfield. He's studying pothole repair made eco-friendly using grit from wastewater treatment. Dr. Liu?
Hello everyone. It's my great pleasure to be here. Today I'm going to talk about my work regarding how to convert the wastewater grit to the load for pothole repair. So Katie will share some slides. So my title is Sustainable Resource Recovery from a Wastewater Treatment Byproduct. So the product we developed is called Grit Assisted Patch, Gaap. So the story originates from the wastewater treatment plant. So at wastewater treatment plant, we don't just treat waste in the wastewater. We don't just have used water. We also have lots of impurities like some eggshells, coffee grounds, and also some large organic particles. So these particles, these impurities, will be removed from the wastewater before entering the downstream processing units. So, and we call these impurities wastewater grit. So Katie, you can click. So this is how grit looks like. So it's a very nasty stuff. It's super smelly. And the big problem is it contains lots of pathogens. So normally grit cannot be reused, and all the grit in the United States is landfilled. So I'm thinking, can we convert grit to a useful product and for the load infrastructure application? So on the other side, Katie can click. On the other side, we have lots of problems on the load. As you know, pothole, I think almost everyone drive over pothole, and pothole causes lots of money, lots of like millions dollars damage every year in this country. So I'm thinking if I can find a specific material that can encapsulate grit and then convert it to a patch material. Click, Katie, can you click? Like this. So the grit can be stabilized and solidified in this material, and this material can be used to patch the pothole. And to complete this project, I invited another 3 professors. So Katie, can you click? I invited Dr. Qing Xiao from University of Wisconsin-Milwaukee, and his expertise is in transportation engineering. And I also invited Dr. Wang from Marquette University, and his expertise is in construction materials. And since we have lots of pathogens in the wastewater grit, so I also invited Dr. Kiana Young from Wake Forest University. Her expertise is in microbiology. And this project is supported by Milwaukee Metropolitan Sewerage District. And we are now working on the demonstration scale. And MMSD, they provide their load, on their wastewater treatment plant for our demonstration scale test. So Katie, can you move to the next slide? And our proposed approach is after we get the raw wastewater grit, which contains lots of pathogen, we use magnesium oxide and calcium oxide to inactivate the pathogen in the grit. And then we add another very cheap ingredient. It's called monopotassium phosphate. After we add the monopotassium phosphate, we can form a grit CPPC mortar. CPPC here means chemically bonded phosphate ceramics. It's formed by using alkaline earth metals like calcium oxide or magnesium oxide with monopotassium phosphate. After we get this grit CPPC mortar, we can use this mortar for pothole repair. So we call it a grit assisted patch. Can you move to the next slide? Oh, sorry. So the pathogen can be inactivated within 30 minutes, and the compressive strength can reach 2.1 megapar in 1 day. And 2.1 megapar is the required strength by the American Association of Highway. So we got very good data in terms of pathogen activation and compressive strength. Can you move to the next slide? And this is how the product looks like. And we got an asphalt pavement example, and we drill a hole in the middle, and we fill the gap in this hole, and we left the sample outside for over 6 months, which experienced from negative 30 degrees Celsius to positive 30 degrees Celsius. And after 6 months, I took a small sample from the corner, and we checked the bonding between Gaap and asphalt pavement. And just based on our observation, it's very good. But we are still working on the demonstration scale test. We want to test if any traffic stress can have an impact on this bonding. So that's all about our story.
Are there any questions from viewers? Please state your name and affiliation in the chat window when you ask your questions. While we wait for your questions from viewers, I have several. If the entire highway is made of asphalt, does it pollute the environment much more to use asphalt for pothole repair?
Oh yeah, normally the conventional patching material is asphalt-based or bitumen-based. Normally asphalt pavement contains at least 5% bitumen. And normally, I mean, lots of PAH, polyaromatic hydrocarbons were released from the asphalt pavement. And for our patch material, it's totally PAH free. So if we use our patch material, we don't have any secondary pollution problem.
Could you use this new material to make an entire roadway rather than just filling potholes?
I don't think that's possible. Yeah, because we did the preliminary economic analysis, and normally the material cost is a little bit higher compared to the conventional asphalt material. So if you want to construct the whole load, it's normally impossible. Yeah, it's the cost will be too high. But for pothole repair, the cost we have based on the comparison between our product Gaap and the conventional cold patch material, it's very close. It's comparative. So this is why it's better for pothole repair, not for the whole load construction.
Do the solids in wastewater grit contain human waste?
Yeah, there are lots of human waste, and I mentioned it's super nasty. Yeah, and super smelly, and the passaging density is very high. So this is why grit is normally landfilled. We cannot further use. So, but CPPC, this material, chemically bonded phosphate ceramic, this is a very inclusive material. It can encapsulate everything. Yeah, you don't need to do any pretreatment, and everything can be stabilized and solidified in this material very well. And this material is normally used for hazardous waste treatment, like the radioactive waste or the heavy metal containing waste. So it's a super strong matrix that can handle everything. So this is why I want to use this material as a matrix to treat the grit, because it's too complicated.
Have you checked to make sure that all the pathogens in the grit-assisted patch have been inactivated? Could some viruses or bacterial spores survive this treatment?
If you can recall your memory, on my second slide, I show we can inactivate the pathogen within 30 minutes, and after 30 minutes, it should be totally inactivated. So it means proliferation of pathogen cannot happen, cannot come back anymore.
How long do you think the GAP will last in a roadway before it starts to disintegrate?
It's a very good question. So we are now working on the demonstration scale. So we fill the pothole on the real roads in traffic. So it will take some time for us to know how long it will last. But based on the literature review, long time ago, only one researcher, they just used the CPPC alone to fill a pothole, and it can last for over 4 years. But for the conventional cold patch, as you can see on the load, even within like 6 months, some small particles will come out. So the pothole needs to be repaired one more time. So if our assumption can be proved, I'm not expecting 4 years. It can last for 3 years. So we can still have a very good pothole repair. So the team will not go back to repair the same pothole. So it will reduce the labor cost a lot. So this is why our pothole repair material Gaap can be comparable to the conventional patch material, like the cold patch.
Do you think Gaap will be able to handle environmental extremes as well as asphalt?
environmental extreme?
Heat or cold, water, ice?
Oh, yeah, it's a very good question. So for conventional cold patch material, if you can buy this kind of conventional cold patch material from Home Depot or Lowe's. If you check the instruction, normally the application temperature, the lowest temperature you can do is just around 0 degrees Celsius, okay? But if you below this temperature, maybe your patch material cannot be very fluid. So it means you cannot fill the pothole very well. But for our Gaap material, we tested the Gaap material below negative 15 degrees Celsius, and it still can be solidified very well. So it's still very fluid at the beginning. So it means it can handle very extreme weather conditions without any problem. And we also tested our Gaap material at high temperature, like 40 degrees Celsius, and also it works very well. So for both extreme conditions, it works very well. So compared to the conventional patch material, it has more advantage.
What are you doing to improve Gaap's compressive strength, and how are those studies progressing?
Okay, for the compressive strength, we are now using we are using other additives, and we mix other additives with grit and CPPC matrix, and we want to further increase the compressive strength. And based on our current progress, we just found a conventional. I cannot release the information now. We just found a very cheap material that can increase the strength by 1.5 times. Yeah, and we are still working on that. I believe we can further increase the compressive strength, and it will greatly save more cost on the materials fee, and we will put this new material with more actives on the load to test if it can survive in the real world environment.
Can you tell us what you've learned so far from your field tests on actual roadways with traffic?
So far, we are just working on that because of the pandemic. We delay our demonstration scale test a little bit. So my collaborator, Dr. Wang from Academic University, he is working on site these days. I'm not sure the current progress. I think we will know the result maybe in 3 months, within 3 months. Yeah, it'll take some time for the demonstration scale test. And we need to know how many traffics, what's the traffic density over there, and what's the weather condition in the coming 3 months. So there are many factors influencing the demonstration scale result.
What types of additives do you think will improve Gaap's properties, and have you tested any yet?
As I mentioned, I cannot release too much information, but normally, if you can add some pozzolanic material that can react with magnesium oxide or calcium oxide, then will greatly improve the strength of CPPC.
How does the cost of Gaap compare with asphalt?
We only compare the effective patching operation cost. We include the material cost, we include the labor cost, we also include the equipment cost. And our big assumption is our Gaap product can last for, in other words, the survival rate of our patch material can be 1 year, but the conventional patch material, like the cold patch, can only last for quarter year. So based on this assumption, the final effective patching operation cost is very close. If my memory serves well, around $1,700 bucks. Yeah, so it's very comparable. But the prerequisite is our assumption can be proved, and now we are working on this demonstration scale.
How does the carbon footprint of Gaap compare with asphalt?
My collaborator, Dr. Xiaoqing, he's working on this now. I'm not sure the result now, but as you can imagine, asphalt is from petroleum industry. So petroleum industry generates lots of carbon during the production of different products. But for our Gaap product, we don't use any petroleum-based material, so we can, based on our estimation, we can reduce the carbon footprint a lot. And we just use the local waste for the local pothole repair. So we don't have to spend too much money or generate lots of carbon footprint during the transportation of our raw material.
Is there enough wastewater grit available to repair all of the potholes that need repairing?
Yeah, definitely. Based on our estimation, we can only, if our Gaap product can work very well after we prove its performance on a demonstration scale, maybe we can only divert 15% of the wastewater grit from the wastewater treatment plant to the local loads for pothole repair. Yeah, we cannot divert all the wastewater grit. So we have enough wastewater grit available for pothole repair.
Thank you. The archived version of this session will soon be posted at www.acs.org/fall2020 press conferences. Please join us for our next press conference at 1 p.m. today on stopping tooth decay before it starts without killing bacteria. Thank you.